Hello and welcome to Investment Insight. Before we begin, make sure to subscribe and hit the like button. Now let's break down what's happening in the markets today in a clear and simple way. So it's April 20, 2026. And, if you think the AI revolution is still just about, like, chatbots, writing college essays, or generating funny pictures of dogs, you are really looking at the wrong part of the economy right now.
Oh, 100%.
Because we are in the middle of this massive physical, concrete and steel rewiring of the world.
Yeah, it really is a watershed moment. I mean, for the last couple of years, the conversation was, entirely dominated by the software side, like
Yeah.
magic tricks that generative AI could just perform on your screen. But according to recent analysis of global market data, the underlying reality right now is entirely physical. It's incredibly complex, and honestly, it's just much more massive than most people realize.
Okay, so let's unpack this, because our mission for you today is to cut through that software hype. We're going to explore the 5 distinct structural shifts, like the 5 turning points happening in the AI economy right now.
Yeah.
And for everyday investors who are trying to figure out where this market is actually going, understanding these 5 shifts is, well, it's the ultimate cheat code to seeing where the actual money is flowing.
What's fascinating here is that we are watching global supply chains just contort themselves in real time.
Oh, yeah.
We are talking about billions of dollars moving into, like, specialized construction, advanced metallurgy, and power generation. I mean, it's a shift on the scale of building the first transcontinental railroads.
And that leads right into the first major shift we are seeing in the data. The financial pie is just getting exponentially bigger, and it is moving way beyond just buying graphics processing units or GPUs.
Right, the GPU narrative is just one piece now.
Exactly. For a long time, the entire AI investment strategy for a lot of folks basically began and ended with one specific chip company. But the data shows the AI semiconductor market has exploded into this distinct multi-hundred-billion-dollar industry of its own.
The scale is actually kind of hard to wrap your head around. Deloitte's recent projections indicate that overall semiconductor revenue for this year, 2026, will hit $975 billion.
Wow.
Yeah. And out of that near $1 trillion, chips specifically designed for generative AI will account for roughly $500 billion.
That is wild.
And if you look slightly further out, Bloomberg Intelligence projects the AI-specific chip market alone will cross the $600 billion mark in the early 2030s.
$500 billion this year just for the physical brains powering AI. But, here's the critical part for you listening. That money isn't just going to the companies designing the chips. I used to look at this like a gold rush where you just invest in the pickaxes.
Right, the classic analogy.
Yeah, but I think a better way to visualize this is like the government deciding to build the massive interstate highway system back in the 1950s. If you wanted to invest in that, you wouldn't just buy stock in Ford or General Motors because people are going to buy more cars.
All right.
You look at the companies pouring the asphalt, the companies building the specialized heavy machinery, the engineers designing the concrete overpasses.
That highway analogy hits so much closer to the reality of semiconductor manufacturing because the value chain has to expand. Making an AI chip is arguably the most complex manufacturing process in human history.
Right.
And actual order books are proving this out today. In mid-April, TSMC, which manufactures the chips, and ASML, which builds the machines that make the chips, both raised their 2026 financial outlooks based purely on AI demand.
So the money is flowing downstream.
Heavily. Especially into companies that do what's called advanced packaging, because we can't easily make chips any smaller on a flat two-dimensional surface anymore. So these packaging companies are literally stacking chip components on top of each other.
Like microscopic high-rise apartment buildings.
Exactly like that.
Yeah.
And it also bleeds into the specialized memory modules required to store the data and the optical equipment needed to link it all together.
So investors are having to look at the entire industrial supply chain. But if we are building all this incredibly expensive physical hardware, these microscopic high-rises, the software running on it can't just remain this massive, inefficient power hog, right? The brain itself has to adapt.
It does, and this is the second major shift. For a long time, the tech world was waiting for what they called the post-transformer era.
Right, the transformer is the software architecture that made tools like ChatGPT possible.
Exactly. It was revolutionary, but it was also incredibly brute force, just so resource intensive. And a lot of analysts assumed we would just throw it out eventually and replace it with a completely new software paradigm.
Wait, I have to push back here a little. You're telling me we aren't going to invent something totally new that replaces the transformer? Because tech history tells us There's always a new paradigm that wipes out the old one. I mean, we went from dial-up to broadband, from landlines to smartphones.
Sure.
Why is this time different? Why wouldn't a revolutionary new AI brain just make all of this current infrastructure obsolete overnight?
Well, if we connect this to the bigger picture, it really comes down to sunk costs and compounding improvements. The industry has invested hundreds of billions of dollars optimizing hardware specifically for transformer models.
Oh, I see.
Yeah, tearing that all down is economically unfeasible right now. So instead of a revolution, we are seeing a massive, highly profitable evolution. The models are becoming hybrid systems.
Right, and the data on these hybrid systems is just wild. We're seeing the rise of what's called a mixture of experts, or MOE structure. Let's look at a recent model called DeepSeek V3. It has a massive 671 billion parameters. And you can think of parameters as like the neural connections in its brain. But when it actually processes a piece of text, a single token, it only activates 37 billion of them. And Alibaba's Qwen 3 model is doing something similar. It operates with distinct thinking and non-thinking modes to save energy.
Exactly. And the mechanics of why that saves energy are just crucial to understand.
I like to explain it to people like a smart house. Imagine you own a massive 100-room mansion. In the old brute force days of AI, if you wanted to walk into the living room to read a book, the system had to turn on every single light bulb, the air conditioning, and the television in all 100 rooms of the house.
Just a spectacular waste of energy.
Exactly. But with a mixture of experts model, the AI knows exactly what you are doing. It only turns on the specific expert circuits, like the lamp and the AC in the living room, while leaving the rest of the mansion completely powered down.
And that smart house evolution is where the immediate financial returns are. Now, to be fair to your earlier point about new paradigms, we are seeing newer non-transformer models emerging in the research labs.
Right.
For example, there's an architecture called a state-space model, with Mama 3 being a recent iteration.
How does a state space model work differently than a transformer?
Well, a transformer processes information by looking at every single word in a document all at once to understand the context. It's like trying to read a book by keeping every single page laid out on a massive table in front of you simultaneously.
That sounds exhausting.
It is. It requires a massive amount of short-term memory. A state space model, on the other hand, reads more like a human. It reads page 1, remembers the core context, and carries that summarized memory onto page 2.
Oh, that makes sense.
Yeah, it's much more memory efficient. But while those are pushing boundaries, they just aren't the mainstream commercial drivers today. The big money is still pouring into making the transformer mansion more efficient.
Because what we are actually asking the AI to do is changing fundamentally, which pulls us right into the thirds of shift happening right now. We are moving from generative AI to what the industry calls agentic AI.
This is a massive leap in utility.
Okay.
Generative AI creates things, a block of code, an email draft, a picture. Agentic AI takes independent actions across multiple systems to achieve a goal.
And here's where it gets really interesting. Think of generative AI like a brilliant intern. You ask them to research a company, and they hand you a beautifully formatted report. It's helpful, but the work stops there.
Right.
Agentic AI is an executive assistant. They read that same report, realize the data means you need to fly to a manufacturing plant in Ohio immediately, so they access your calendar, book your flights, reserve a rental car, and send an email to the plant manager, all without you ever typing a command.
And getting AI that level of autonomy requires a completely different hardware profile.
How so?
Up until now, the dominant phase of AI was training, shoving the entire internet into the brain so it could learn. Training requires thousands of GPUs crunching massive parallel data sets all at once. But an executive assistant booking a flight isn't training, it's executing a task in the real world. We call that inference.
And inference breaks the monopoly of the GPU.
Precisely. To handle inference efficiently, you don't just need graphics processors. You need central processing units, or CPUs, which are better at sequential logical tasks. You need massive amounts of highly responsive memory to hold the data while the AI works. You need advanced networking to connect to different servers. And increasingly, you need application-specific integrated circuits, or ASICs. Yeah, these are custom-designed chips built to do one highly specific task incredibly fast, rather than a general-purpose GPU that can do a bit of everything.
And the recent market analysis totally backs this up. Morgan Stanley recently highlighted this broadening of the hardware market. We're seeing Google discussing new inference chips with Marvell, and they're expanding their AI CPU cooperation with Intel.
Yep.
The big cloud providers like Meta, Google, Amazon, They are aggressively locking in custom chip deals.
Yeah.
They aren't just stockpiling GPUs anymore. Meta and Google are extending their custom silicon deals with Broadcom deep into the late 2020s and 2030s. And Amazon just secured a jaw-dropping $100 billion 10-year tech usage deal with Anthropic.
They are building comprehensive, interconnected computing ecosystems. As an investor, the premium is shifting from holding the one company that makes the GPU to identifying the companies that build the memory, the networking controllers, and the custom logic boards that make the whole system function seamlessly.
But wait, I mean, having millions of these agentic AI assistants running around the internet 24/7, booking flights, executing stock trades, and managing supply chains, that sounds incredibly taxing on the physical infrastructure.
Oh, it is.
It requires a monumental amount of electricity. Which brings us to the fourth structural shift, the power bottleneck.
This is perhaps the most absolute, unyielding physical constraint on the entire AI boom. Electricity, the cooling required to stop the servers from melting, and software efficiency are becoming the actual metrics that determine an AI company's valuation.
Let's put some numbers to this because it's not just a minor power bill increase. Recent data shows big tech AI infrastructure spending could pass $800 billion this year.
It's staggering.
And Morgan Stanley estimates that U.S. data centers might need up to 80 gigawatts of power by 2028. To give you some context on what 80 gigawatts means, New York City, with all its skyscrapers, subways, and millions of people, uses about 10 gigawatts of power at peak demand.
Wow.
So we're talking about needing to build the equivalent of 8 New York City's worth of power generation just to feed these data centers. The U.S. Energy Information Administration projects American power consumption to hit absolute record highs in 2026 and 2027.
And that physical reality is colliding with the limitations of our power grid. You can't just build a nuclear power plant or a massive wind farm overnight. The permitting, the community pushback, and the physical construction of power lines takes years, often decades.
It makes me think about building a massive state-of-the-art skyscraper. You can have the most beautiful architecture, the fastest elevators, and the most expensive marble in the lobby. But if the city's underground water main connecting to the building is only 2 inches wide, you can't flush the toilets. It doesn't matter how great the building is. The infrastructure bottleneck ruins the entire project. So are we just stuck waiting for power plants to be built?
No, because the industry is aggressively fighting a war on inefficiency. And one of the most exciting battlegrounds here is a technology called silicon photonics.
That sounds like a weapon from a sci-fi movie. What actually is silicon photonics?
It's brilliant engineering. In a traditional server rack, data travels between chips using electrical signals moving through standard copper wires. The problem is, pushing electricity through copper generates a massive amount of heat.
Right, like a toaster.
Yeah, exactly. Which means you have to spend even more electricity running giant air conditioners to cool the wires down. Silicon photonics replaces those copper wires with microscopic lasers built directly onto the motherboard.
Like lasers on the motherboard.
Yeah. Instead of electricity, it uses light to transmit data through tiny fiber optic channels. Companies like NVIDIA, Marvell, and Tower Semiconductor are heavily investing here because moving data with light generates almost zero heat, dramatically slashing the power requirements of the data center.
So we are physically swapping out the materials on the motherboard to save power. But the software is being forced to adapt too, and interestingly, international politics is driving some of that innovation.
It really is a strange paradox. Because of ongoing U.S. trade sanctions, Chinese tech firms do not have legal access to the absolute cutting-edge AI chips. But rather than giving up, they are being forced to ruthlessly optimize their software so it can run on weaker, older generation chips.
So by starving them of the best hardware, it's basically forcing them to become better software engineers.
Essentially, yes. This constraint is creating a highly competitive advantage for them in inference costs. They are learning how to squeeze every single drop of performance out of limited, low-power hardware. The ultimate winner in the next decade of AI isn't necessarily the company with the smartest model. It's the company that gets the most tokens, the most output per single watt of energy consumed.
We are also seeing this power constraint push AI entirely out of the data centers. Right?
Yes, this is the rise of edge, or on-device AI. We are seeing companies like South Korea's DeepX working with auto manufacturers like Hyundai. The goal is to put dedicated AI processors directly into cars, smartphones, and factory equipment.
Oh, I see.
If your car can process its self-driving data locally on its own computer, it doesn't have to beam that data across the country to a server farm and wait for a response. Processing at the edge of the network saves massive amounts of grid power and eliminates the delay in response time, which is, critical if you were relying on AI to hit the brakes on a highway.
Now, you mentioned the U.S. trade sanctions forcing software optimization. That political reality naturally pulls us into our fifth and final structural shift: geopolitics and the splintering of the global tech ecosystem.
This is a profound departure from the last 30 years of globalization. National security concerns are now physically splitting the semiconductor supply chain into allied blocks. AI is no longer viewed simply as consumer technology. It is classified as critical defense infrastructure.
And looking at the policy data neutrally, we can see how aggressively this map is being redrawn. The U.S. Congress recently pushed forward the MTCH Act, and while it was slightly scaled back from its initial draft, it still heavily restricts ASML, that vital European machine manufacturer we talked about earlier, from providing their advanced DUV immersion equipment to China.
And we should clarify what DUV immersion equipment is because it highlights how precise this bottleneck really is.
Hey, what is it?
DUV stands for deep ultraviolet. These machines are essentially hyper-advanced microscopic stencils. They use specialized light, projected through a layer of purified water, to print the impossibly tiny circuitry onto a silicon wafer. If you don't have access to these specific machines or the technicians who service them, you physically cannot manufacture modern high-performance chips.
Right. Under the current Trump administration, the U.S. is firmly treating these AI components as strategic, economic, and military assets. They are actively coordinating with allied nations to throttle China's high-end chip production capabilities. But China isn't just standing still.
Far from it. China's current 5-year plan heavily subsidizes technological self-reliance. And while they might be restricted from buying the machines to make the bleeding-edge AI chips, they are pivoting hard to dominate a different part of the market, which is mature nodes.
What exactly is a mature node?
Mature node is industry jargon for older, fully perfected chip designs, specifically the 22 to 40 nanometer sizes. These aren't the chips that train ChatGPT. These are the blue-collar workhorses of the global economy.
Okay, so what do?
They are the chips that run your microwave, manage your car's anti-lock brakes, and control hospital ventilators. I mean, you don't need a $40,000 AI chip to roll down a car window.
Right.
China is aiming to control 42% of global mature node production by 2028. By cornering the market on these foundational chips, they are securing a massive geopolitical lever over the everyday consumer economy.
To make this easy to visualize for everyone listening, think about how the global tech economy used to work. It was like the world shared one giant global supermarket for tech parts. Every country shopped in the same aisles, bought from the same shelves, and relied on the exact same shipping lanes.
Yeah.
Now, because of these national security policies, we are building two separate exclusive membership clubs that simply do not trade with each other.
This raises an important question for investors. How do you navigate a world with two clubs? This isn't just a temporary regulatory risk that might blow over with a single new trade agreement. It is a permanent physical fracturing. The supply chains, the customer bases, the software protocols, and even the physical product designs will look completely different depending on which geographic club a company belongs to. You can't just invest in a tech company and assume they have a seamless global market anymore. You have to know exactly which club they are legally allowed to sell their products to.
It really requires a completely different analytical lens.
Yeah.
Now, before we bring all of this together, I know some of you listening might be wondering about some of the wild, futuristic tech buzzwords you see making headlines. Things like quantum computing or neuromorphic chips. For example, Terra Quantum is currently pushing for a massive $3.25 billion IPO. Where do those fit into these 5 turning points?
We hear those terms constantly, but we need to categorize them correctly for investment purposes. Quantum computing uses subatomic physics to process data, and neuromorphic chips are physically designed to mimic the neural pathways of the human brain.
It's all me.
They are absolutely fascinating technologies, and governments are funding crucial research into them. But right now, they are just call options on the distant future. They are where AI was 10 or 15 years ago. They are not the technologies driving today's revenue.
So focus on the present.
Yeah. If you are looking at what is actively capturing the hundreds of billions of dollars in the hardware market right now, it is the hybrid transformers, the agentic CPU systems, and the silicon photonics we just discussed.
So what does this all mean? If we step back and look at the whole board, the core takeaway for you is that the AI revolution isn't just a software story anymore. It is a massive systems story. It's about hybrid software architectures that act like smart houses to save energy.
Yep.
It's about a much broader hardware ecosystem where custom chips and advanced memory are just as important as GPUs for getting work done in the real world. It's about fundamentally redesigning motherboards with lasers to survive an unprecedented power grid bottleneck. And it's about navigating a geopolitically divided map where the tech supermarket has split into exclusive, competing clubs.
That is the exact reality of the market right now. And it leads me to a final thought I want to leave you with, building on the reality of that massive power bottleneck.
Okay, let's hear it.
We spend all our time agonizing over which silicon designer or which software engineer is going to win the AI race. But if physical power constraints, the actual gigawatts of electricity, are the true unyielding bottleneck for AI's growth, what if the most valuable AI companies of the 2030s aren't software developers or chip designers at all?
Wait, really?
Yeah. What if the real winners are the next generation energy companies that figure out how to cleanly, reliably, and massively power this new intelligence grid?
Wow, that completely flips the script. You might be hunting through the tech sector for the next big chip stock, but you should really be looking at the utility sector for the company that provides the water to the skyscraper. That is an incredible lens to view this market through. Thank you all for joining us on this deep dive into the real physical infrastructure of the AI boom. Don't forget to subscribe and hit that like button.